Okay, hello everyone. Welcome back to Path for Cloud. So, have you ever felt like your Kubernetes cluster is a wild west and with every pod talking to every other pod? Yes, that's true. By default, in Kubernetes, all pods can talk to each other. Yes, they have the full connectivity. It is like kind of a good start in a real world production environment, right? But again, this comes along with a massive security risk, right? Because if you are having a open door policy for everyone in your cluster, right, and which is all the time, right, that's a kind of risk, right? So this is where a Kubernetes network policy comes in. So in today's video, we will gonna discuss how Kubernetes network works by default, and if you want to take your control on that network, then how you can play with the network policies, right? So network policies are essentially a kind of firewall rule for your pod. These are a firewall rule to your pod where you can define uh, this is a pod where you can define, right, what allow inside the pod and what is like externally can go outside from the pod. That's what we can say in this, right? So how do they work? Because as I mentioned, this is something that you can control with the help of network policy, right? So again, a network policy, what is network policy? So network policy is nothing. It's again a API object which we can create where you can define your rules, whether it's a ingress and there is something called egress. So what is ingress and egress is? Ingress is something what is coming inside and egress is something which is going outside of your pod, right? And they use a labels, right? How you can set your policies and you can define, okay, what is on which traffic or maybe which communication from a particular pod, whether an ingress is allowed or denied. Again, same case with the egress, whether it's allowed or denied. They use a label. They take a leverage of labels which we put, right? We already understood what label is because they use labels to select which pods the policy applies to and then define rule based on the pod selector. We have something called pod selector. We have name selector. I will explain where you can use of port selector, where you can use of name selector, and even if you can have a number of blocks, right, using a cider, that also you can control because it's all about the isolation. Okay, let's understand with this an example. Let's say you have a web application pod. This is an example, and you have a web pod, okay, and you have a DB pod. You have web pod and you have a DB pod. You only want your web app to talk to your database and nothing else. So for DB pod, we can define an ingress rule, ingress policy, where we can put a rule like if the traffic is coming from the web pod, that will be allowed, and anything else is coming, that is something denied, right? So you would create an ingress network policy on the database pod specifying that only traffic from pods which the label has web pod. Let's say it has a label is app equal to web, for an example. If the traffic is coming from that pod and that pod is having a label called app equal to web, then it will be allowed, otherwise it will be denied. Or maybe there is a different scenario. You want to restrict a pod like DB pod or any other pod to sending data outside of your cluster, maybe to suspicious external IP or maybe inside your cluster where you don't want to send or talk to other pod. So there, what you can do, you can define an egress policy. Again, egress policy will also take effect of pod selector, name selector, and IP block, which can prevent data, right, by ensuring your pod only talk to your trusted destination which you define inside your application. All right, now the question is how we gonna define a network policy. So let me explain this manifest file for network policy. Okay. So again, we have four major section. One is API version, then we have kind, metadata, and spec. This is something that it is common for all, right? Only the thing is you need to make sure that whenever you are defining which manifest, you need to make sure what API version you need to talk, what kind you need to put. Metadata is important where we just give the name of your object, or maybe if any other labels you want to set, right? Let's say app equal to web I want to set. That's what that label you can. And the spec is the most important where we actually define a body of your object. Okay. So this is a kind of example file I have created where I just want to, or maybe I just wanted to explain a different scenario, because by default we learn everything is allowed to everything. Every pod can talk to every other pod. But if you want to deny everything, right? Ingress, like I don't want that anyone can come to me and talk. No, I want everything to be blocked. So what you can do is you can see API version. Here the API version is networking K8IO V1. Kind will be the network policy because that's what we are trying to define. And the metadata, I am just giving a name to my policy. Deny all ingress. If you want to specify to that particular namespace, then you need to define a namespace here. Otherwise, if you don't define, then it will assume you are defining that particular network policy in a default namespace. All right. Then we have a spec section. Under spec section, you have a few important stuff which I will talk in a bit. The first one you can say pod selector. You are defining this policy, but to which object, right? So this thing you will define here. I am defining this policy to a pod selector which has a match label is app equal to my app. So these three lines says if a pod is having a label called app equal to my app, then on that pod this policy will be applied. And what type of policy? I am defining a policy type is ingress. If you are not specifying any rule for this policy type, it will assume that you are denying everything. That's what it is saying. Deny all ingress, right? I'm just saying that, okay, apply a ingress because the only two types of policy we have. One is ingress and the other one is egress. So with ingress, I am saying deny everything because I'm not putting any specific rule. So that by default, everything will be denied. Whereas in the second example, if you see, it is saying allow traffic to my app pods only from pod in the same namespace. Here doesn't matter from which namespace the traffic is coming, everything is denied. But here a scenario is a little bit different. I want to allow only a traffic from the same namespace. If a traffic is coming from a different namespace, then that will be denied. And how to do that? Till here it's same, right? Policy type ingress I am defining. But for the ingress policy, I need to define a rule. Like what rule I need to allow. Like accept this, everything will be denied. So for the ingress, what I'm saying is if ingress from like from where the data is coming, pod selector, I am just giving an empty block. That means that whatever the pod sitting in the default namespace that can talk to a pod, which pod that pod have a label called app equal to my app. All right, that's how that you can define. In the third, let's say I want to allow only from the another namespace, not from the same namespace. Then what you need to do is I am defining this policy for the default namespace. In the default namespace, there is a pod which has a label called app equal to my app, and I want to put a policy type as an ingress. And for that ingress, the rule is namespace selector. See, earlier you were putting a pod selector, but here I'm saying a namespace selector. That means that whatever the traffic is coming towards this pod, and if that traffic is a particular pod which is sitting inside a monitoring namespace, that will be allowed. Otherwise, if the traffic is coming from a same namespace also, that will also be denied. Because I am just giving one rule here, and the rule says namespace selector is monitoring because it uses its label, right? That's what we understood here. It uses a label for these rules to be applicable. Let's say if you want to allow a ingress but on a particular port, then how you can do? Same thing in ingress. I want to allow traffic from a port called front end, and if that front end port is talking to me on port 80, then only it will be allowed, otherwise it will be denied, right? And the fifth example is if you have a set of IP like CIDR block there you want to do, then you can do. And here we have a egress example. Till now we have discussed only ingress. Like if you want to allow from your backend port to talk to a different IPs, then you can set it. Egress, okay. Ingress is by default allowed because I am not putting any role, so obviously it will be allowed. But when I am sending a data outside of this port, that data will be allowed only on this CIDR block and within this port number. So that's how that you can define all these rules. So what I have done is just to explain this, I have created a few namespace, few ports in default and other namespace, and then we'll try to see the connectivity without namespace, this network policy. And when we put a network policy, then how will be the behavior? Okay, so let's start. Here I'm creating a dev namespace and I'm just putting some labels on this. These are the annotation. It's a kind of optional thing. If you don't want to put, fine, you will ignore it. But to make a like good practice, right? Just to understand like what exactly this namespace is doing, and if you want to make some changes to that particular namespace, to whom you want to connect. So all these things you can put as an annotation to this. Then I am defining a pod inside that dev namespace. You can see I am defining a pod called dev pod inside a dev namespace. And I'm using a BGBox image just to check the ping connectivity. And to keep it live, I'm just assigning a sleep binary to that particular shell so that it will keep on running. Similarly, there are few ports in the default namespace using the same image. I'm not defining any of the namespace, so by default it will go to default namespace. It's a dev port 1, dev port 2, dev port 3. All these are common, right? Whereas in the dev 4 port, I'm using a different image called curl images because I want to see a port 80 connectivity towards my Nginx port. Because you can see here we are defining an Nginx port, and I want to see whether this particular port is able to connect to Nginx without network policy. And when we put the network policy, then what will be the behavior? And to access that, obviously we need to expose. So I am exposing this as a service called def Nginx SVC for this particular Nginx port. Okay, and these are some test scenario which I have put, which we just now will start. So here what it is saying is without network policy, all ports can reach to each other because they are by default whitelisted. There is no blacklisted, something called blacklisted in the Kubernetes. If you want to do something, you need to allow, you need to deny, otherwise everything will be whitelisted. They are just asking us to check the connectivity without network policy, whether you can ping or not, whether you can curl that particular Nginx port on port 80 from def port 4 or not, because later we will block def port 4 egress traffic towards this. We will see whether that will be happening or not. And then it will assigning a different network policy demo because I have the four network policy I have created for these four demos. Okay, so let's come to our cluster now. So here we have our cluster, and I think I have already pulled those images here. Yes. So what I will do is I will quickly create this pod setup scenario for this demo, And you can see it has created a dev namespace. Inside a dev namespace, it has created a dev pod, and in the default namespace, it has created a 5 pod, 1, 2, 3, 4, and Nginx. And for the Nginx, it has created a service called def Nginx service. Okay, so let's see how it looks. If I just want to a wide output for this one and kubectl get pods hyphen n dev, because I want to see a pod from the dev namespace. If you want to see another namespace, so obviously we have learned you can pass a hyphen n flag and then the name of the namespace. Now let's quickly see if I can talk to this dev namespace pod to this pod inside default namespace. Okay, there was a typo. We need to give a space here. Oh, dev pod in sitting inside a dev namespace, right? So you can see it is pinging. If I want to see, because this is a cross namespace communication and which is allowed. If I want to see inside same namespace, that is also allowed, because from the dev pod 1 I am trying to connect to pod 3 and it is able to ping. All right. As of now, you can see we don't have any net pol. I think it's the short form for the network policy. Yes. And how you come to know? You can check this API resources and just grep for network. And here you can see for the network policies, the short form is net pol. And that's what we have ran and we are getting nothing. So let me take to the first demo first. So in that first demo, what we are saying is dev pod 1 in the default namespace are pingable only from dev pod from the development namespace. That means we are saying ingress traffic from dev pod 1 will be blocked from everywhere except a pod called dev pod. So we are putting this network policy. This is just the name, and I'm applying this policy on the default namespace where I'm saying the pod selector is dev pod 1. That's the pod is running in the default namespace. All right. What is the policy I am applying? I am applying a ingress policy, and in this ingress policy, I am just giving a name rule called this ingress from namespace selector. Okay, let me just take this copy and then we'll, because here it's a very important thing to discuss. Okay, and if I just take it here, see, in the first example, what it is doing is, maybe the space is not good in the notepad, but anyways, we just need to understand. Here I am just putting a kind of AND condition. First, I need to match a label from the namespace selector. If my any of these label is matching to that namespace selector, then only it will go to the, let's say if your pod is matching to this label, right? But your namespace is not matching, then this rule will not be applied. It will be ignored. Whereas in this example, what I'm saying is if namespace is this, and if any namespace, not this namespace, if any namespace, if any pod is running with this label, that will also be allowed. Because here you can see this is a different array. So this is a kind of OR condition and this is an AND condition. Because here we are saying name selector is also match and the port selector also should be matched, then only the this rule will be applicable, otherwise it will be ignored. But in this case, if your namespace selector matches whatever the port sitting inside this namespace, that will be allowed. Or in any namespace, if a port is having this label, that will also be allowed. All right, so this a small thing can make a big difference in your network policy. So whenever you are applying this, right, make sure that you will check all these things. Okay. Now I'm saying this namespace selector where I just want to see if any of this, right? Because by default, this is the name default label set if you are not giving anything. But if you are giving anything, then it will be overwritten, right? So if you are not giving any namespace while creating your namespace, any label, if it was not given, then it will be set as a name equal to the name of that particular object. But if you are giving anything, then it will be overwritten and it will not be matched, right? In this case, it will not be matched. Let's say if this is the scenario and I have put this label, right? I have put the label here, and if I am not putting this environment equal to test, then it will not be matched because by default there is no label. These labels will come in picture. That's why I just put here to define you. Okay. Now within this namespace, I have to find a this port, and if that port is matching and if they're trying to talk to this default port 1 in the default namespace, that will be allowed. It is a 46 number file. So let's quickly apply it. Kubectl create hyphen F. Before that, let me show you kubectl get ports hyphen o white. Now I want to apply. No, I just want to check the connectivity from the port 2 towards port 1. Okay. Now it is pinging, right? Now let's quickly apply that network policy. Kubectl create hyphen F and it will be a 46. Applied. If you want to see kubectl get netpol, it is applied. And if I want to try now, you can see earlier it was able to ping, but now it is not going. Why? Because we have put a condition here. If I want to do the same thing from dev pod, from the dev namespace, and if I want to try this IP, it is allowed. That is the only thing is allowed. Kubectl describe network policy this. So within this you can see it is allowing ingress any port from only this stuff. Otherwise everything will be denied. That's how it is working, right? Let's see a second demo. In second demo, what I'm saying is def pod 2 are pingable from def pod 1 in default namespace, not by any other pod from any. Now we just see everything was pinging to each other. But when we put a network policy, now the dev pod 1 is only reachable from the port which is running inside the dev namespace. That's what we tried. It was not going through, right? Because here you can see it was stuck. Similarly, it is saying dev pod 2 is only pingable from the dev pod 1. If I just want to see the same thing, but from the dev pod in the dev namespace, if I am trying to ping a dev pod 2, as of now, no policy. So it is applying. It is pingable, right? Now, let's apply a policy called this one. It is applied. Now let's try again. It stopped. But same thing, if I try from the dev pod 1, it will be allowed. What is the dev pod? Dev pod 1, and I want to ping a this pod. It is allowed, right? So you need to understand whenever you have a requirement, right? How you can control, how you can put. So these things, if you don't put any of the policy, by default it will be allowed, right? If you put a ingress here, then everything will be denied. And if you want to specifically allow something, then you need to define this rule. Otherwise, nothing will be allowed. Similarly, in the demo 3, allow all incoming traffic to dev port 3 in the default namespace from anywhere, but dev port 3 can't reach anywhere. Now, let me quickly clear my screen. Kubectl get port hyphen o wide. Let's try if as of now without network policy, can we reach to Nginx port? Yes, we are reaching, right? Now it is saying that allow all incoming traffic to port 3. That means that uh, we are just saying that in okay, it is I think it's wrong, but let's see. It is denying everything to port 3. So what I'm saying is ingress, what I'm saying is allowing all inbound traffic. If you are putting this ingress, right? If you don't put this, then that way also it will be allowed. But if you are putting the ingress, then you need to define the rule. So what rule I am defining here is, it is correct only. I am saying everything is allowed, whether it's coming from the same namespace or any other namespace. Whereas egress, I am saying deny all outbound traffic. I'm just giving an empty block again for the egress. It is a 47. You can see that from dev port 3, I am reaching to Nginx port, but when I'm just applying this network policy called 48, and now if I'll try to reach Nginx, it is not going through. But whereas if I try to reach my from port number 2 to port number 3, I think port 2 maybe we have put some policy, but let's see. You can see port 3 is having this IP, right? 3602. It is accepting a network from anywhere. But when I'm trying to outside without network policy, it was going. Then we have applied the policy and now it is not going. All right. So that's what that you can define a egress traffic also, like if you don't want to apply. And within the egress also, if you just want to specify on a particular port, which we have in demo 4, you can see only deny port 80 from dev port 4. I'm just defining a port number, uh, denying port number 80. Again, in the default namespace on port number 4, everything is allowed, but egress is only and only 80 is denied. So how you can define? You can put a egress, and under egress you can define a port. You can define a port selector. You can define a name selector. You can define a IP block, and even you can define your port as well. So I'm saying this AND port is help you to put a defined range, right? So what I'm saying is egress, like outside, if a protocol is TCP and the port is sitting somewhere in between 1 and 79, that will be allowed. Or if it is sitting 81 to this, you can see that 80 is not there. That means that 80 will be denied. As of now, let's see if port 4 can reach to Nginx. Let me clear again. And let's quickly list out our port. I want output. Okay. Now, if I just run kubectl exec -it def port 4 and I want to do a curl called nginx port on port 80. You can see I am getting the output without network policy. But let me allow this policy. Now I have applied the policy, and if I try to put now, you can see there is no response, right? There is no response on this. Whereas if you go to a different or maybe same port, if you want to try to ping, okay, maybe Ping is not allowed in this because we are using a curl image for this port, but uh, okay, maybe we cannot test, but yeah, def pod, if you go from, let's say, def pod 3 to def pod 4, it is accepting, but it is not going towards Nginx on port 80. What is, okay, it's hyphen 3. Ah, come on. You can see uh, why it is. Okay, maybe def pod 3 we have a different policy we already put. That is the reason maybe. Let's see what policy we have put. Def pod 3 is only allowing the egress, but outside is not allowed. That's why, right? Everything is blocked inside pod 3. That is what it is not reaching. Anyways, so that was the policy, network policy you can define in your environment based on your requirement, right? Like if you have, we have taken this example, web pod and DB pod, where you want DB pod to be communicate only from the web pod, then you can just define a ingress, and ingress, under ingress, just put a rule. If traffic is coming from this, that will be allowed. Otherwise, everything will be denied. So that is the benefit of this network policy. And why is this so important? Because it is enhancing your security, right? Because it is giving you a unauthorized access, or a limit for your pod, for which pod can talk to which pod, right? It will help you to make compliance within your environment, right? Which will make you which will make you kind of if you want to isolate some sensitive data, or like DB we have done, right? And it will help you to debug your issues as well, right? You can troubleshoot in a better way. It will make you easier to find out the network flow as well, right? So that's how that this will network policy help you to understand more and to give you a kind of granular level of control. So it's in your hand which can talk to which, so you can define that way. All right. So that was the kind of fundamental part of securing your Kubernetes cluster using the network policy. All right. Okay. So if you found this explanation helpful, then I would like you to hit that button, like, subscribe to my channel for more tech tutorials, more leading technologies, right, in the Kubernetes, or maybe in any other areas, because that's what we are discussing here. All right. And yeah, obviously, every time you need to kind of check your official Kubernetes document with our Kubernetes videos, because here sometimes what happen is, let me show you, kubectl get pods -n kube system. So here you can see I have defining, I'm using a kind of Weave CNI plugin, which will help you to understand the networking, to make the network inside your Kubernetes. Sometimes if that CNI plugin is not supporting maybe egress or maybe ingress, ingress is, I think, most of the CNI plugin will support, but there are few which might not support your egress, right? So that way you need to understand before you are applying any of the network CNI plugin, and you want this to be applied network policy, then you need to check the document for that particular CNI plugin, whether that is allowed or not. All right. So yeah, that was for the day, and let's see what we will discuss in the next video. Till then, stay secure, stay updated, and happy learning. I'll see you in the next video. Thank you guys. Bye bye.